Scientists reveal shocking 2025 discoveries in the Bermuda Triangle, a region once cloaked in myth and maritime fear, has just yielded secrets that challenge everything we thought we knew. The Bermuda Triangle, a vast and enigmatic stretch of ocean, has long been synonymous with mystery, disappearing vessels, and eerie, unexplainable phenomena. But the revelations emerging from 2024 to 2025 now paint a far more complex picture. One that entwines the brutal forces of nature with subtle, barely perceptible shifts beneath the waves. What if the ocean itself is rewriting its own rules right before our eyes? For decades, the Bermuda Triangle has captivated imaginations. A zone where compasses spin wildly, and tormented sailors whisper of ghostly apparitions and sudden storms. Yet beyond folklore, scientific eyes have struggled to penetrate its depths. Now, breakthroughs in deep-sea observation, technology, and data analysis have peeled back a veil long thought impenetrable. From turbulent undercurrents to disturbing climate shifts, the ocean's behavior here holds clues that could reshape our understanding of Earth's climate and natural disaster patterns. What makes this region so treacherous? And could the forces uncovered here foreshadow larger global consequences? In the unfolding saga of oceanic mystery, these latest discoveries border on the unsettling. Each revelation exposes a new layer of complexity, drawing us ever deeper into an intricate web of environmental and geophysical forces. At the heart of this turbulent expanse lies an invisible conveyor belt that powers the climate and controls the weather across the Atlantic and beyond. Known as the Atlantic Meridional Overturning Circulation, or AMOC, it acts like the planet's heartbeat, redistributing heat and regulating storms. Recent studies reveal that this crucial system is showing signs of alarming weakening, with the Bermuda Triangle somehow at the epicenter of this phenomenon. But why here, and what could trigger such dramatic changes? Beneath the deceptively calm surface lurks another danger: vast deposits of methane hydrates. These frozen bubbles of gas, trapped within the seafloor's sediment, have remained stable for thousands of years. Yet subtle shifts in ocean temperature and pressure might be unraveling this fragile cage. When released, methane gas can alter water density and fuel sudden violent eruptions from the depths, potentially explaining some of the extraordinary disappearances historically reported in this notorious zone. But the mystery deepens. The Gulf Stream, a powerful ocean current that feeds into and out of the triangle, has been altering its flow patterns in unexpected ways. This disruption affects more than just local weather. It reverberates across continents, influencing the frequency and intensity of hurricanes and storm systems. Scientists now suspect that anomalies detected in 2024 and 2025 are not isolated events, but signals of a larger, systemic shift in oceanic behavior. Meanwhile, climate change intensifies the stakes. Rising air and sea temperatures exacerbate the instability of this delicate marine environment. Sudden, violent storms appearing with unprecedented speed and ferocity have become more frequent, baffling meteorologists and endangering lives. The Bermuda Triangle no longer seems just a local enigma, but a barometer for deep and growing planetary distress. One of the most unsettling recent findings involves ocean temperature anomalies measured at abyssal depths. These subtle increases in heat, previously undetectable, suggest altered thermal structures beneath the surface. Such shifts could destabilize the equilibrium of underwater currents, supporting marine ecosystems and large-scale ocean circulation. The implications stretch far beyond disappearing ships. They hint at an ocean on the brink of transformative change as scientists delve further. New high-resolution sonar and satellite data reveal unexpected underwater methane plumes rising along fracture zones in the seafloor. These eruptions, occasionally violent enough to disrupt the surface, may contribute to the formation of sudden, localized gas pockets. Dangerous for vessels caught unaware, these pockets might explain numerous reports of rapid sinkings without clear cause. The ocean is in motion on a scale and intensity only now coming into full view. What binds these discoveries together is a narrative of fragile balance tipping toward chaos. The Bermuda Triangle emerges not just as a geographical oddity, but as a front line in the planet's accelerating climate saga. The weakening of the AMOC, the destabilization of methane reservoirs, and changing ocean currents form a triad of interconnected forces rewriting the rules of this historic sea. Confronting these realities forces a reconsideration of the tales and legends surrounding the triangle. While piracy and supernatural theories fade under scientific scrutiny, new dangers arise from the natural world itself. volatile methane bubbles, shifting currents, and a climate system pushed to its limits. The ocean's hidden power, once respected and feared in myth, is now revealed in raw and measurable terms. This knowledge carries with it a haunting awareness. If the Bermuda Triangle is symptomatic of broader planetary shifts, then the fragile lines separating stability from disaster have thinned dangerously. Extreme weather events and sudden natural occurrences may no longer be unpredictable anomalies, but heralds of systemic transformation underway. In the end, the Bermuda Triangle stands as a chilling reminder of our limited grasp over nature's depths and dynamics. Beneath its swirling waters lies not only a history of mystery, but a future of pressing uncertainty. The ocean's secrets are unfolding, and with them come urgent questions about how humanity will respond to a world where climate and oceanic forces converge with unforgiving intensity. The shadows beneath the waves beckon, not just for discovery, but for understanding, a truth lurking in cold depths, awaiting those willing to face the ocean's silent, shifting dangers.